Welcome to my presentation, and today I'll be presenting my analysis on forecasting Australian retail trade using regression model. Here's the outline for my presentation. In this presentation, I use regression analysis to forecast Australian retail trade data. I saw the data from ABS Retail Trade Australia Catalog A501, especially Table 21. For exercise 1, I use seasonally adjusted data. For exercise 2, I use the original monthly values. The sample period runs from February 2022 to January 2025, measures in millions of dollars. Now I move on to how I apply this dataset in Excel for the regression model. First, I prepare my dataset. The dependent variables is the original sales trade value from February 2022 to January 2025. I add a 10 variable labeled from 1 to 36 for each month and also create 11 dummy variables for February through December using January as the base month. Next, I open the data analysis tool, select regression, and set the E-range to the original data and the H-range to the 10 variable plus all 11 dummies. I check the labels, residuals, and set the output to display in the new worksheet. Let's highlight the key results. The intercept is 3,280 million, which represents the baseline retail sales in January. The time coefficient is roughly 20.97 million, indicates that retail sales increased by about 21 million each month on average. November and December dummies are highly significant, reflecting the holiday sales surge. The elsewhere is 0.97, meaning the model explains 97% of the variation in retail sales. The F statistic is 62.47, confirming the model is statistically significant overall. To generate the sample forecast, I create dummy variables for the future months in the same way I did for the original data. I use the estimated distribution equation to calculate the value by using the intercept plus the coefficient for time and the month dummies multiplied by its variable. Next, let's look at the forecast results. Here you can see the charts combining the actual, fitted, and forecasted online retail sales from February 2025 to January 2026. The blue line shows the actual sales from the original data. The orange line presents the fitted values. Those are the predictions within the sample period generated by regression model. The green line extends beyond January 25 and show the out sample forecast for the next 12 months. I've also included the light orange trend line, which illustrates the overall upward movement in sales over time. And we can see the fitted values closely match the actual data, which suggests a strong model fit. There's a clear seasonal pattern with notable peaks in November and December, most likely due to holiday shopping and end of year spending. This pattern repeats each year and is well captured by dummy variables included in the regression model. Looking ahead, the forecast value maintains this seasonal structure. The model predicts continued growth in sales with expected surges again in November and December 2025. Meanwhile, months like February and March are forecasted to remain relatively flat, consistent with previous seasonal lows. This forecast can help retailers plan inventory, staffing, and marketing around expected demand fluctuations. Next, I discuss diagnostics and model issues, including a note on autocorrelation. First, let's look at the residual plot. Ideally, residuals should scatter randomly around zero. In our plot, residuals form a slight U-shape. They start above zero, dip in the middle, then raise again toward the end of the sample. This indicates the model may be missing a non-linear trend or other structural pattern. November and December are significant as expected. However, some months like March, May, June are not significant. This may raise from month to collinearity among the 11 dummy variables. Excel does not report variance inflation patterns, but include many seasonal dummies alongside a time trends arrays metrics. The plot shows the error from 1 month tend to be similar to the errors in the next few months. Positive autocorrelation at lat 1 to 6, later on lat 10 to 18, the error tend to alternate in size negatively autocorrelation, which means the model leftover patterns are not fully random. By using fixed dummy, the model assumes that the seasonal effects are constant over time. If customer behavior change, the fixed effects might no longer hold. Let's retake this regression model and compare it to the winter exponential smoothing model from our previous assessment. This model performed well in terms of technical fit, 97% of the variation in retail trade over the same period. The time variable is highly significant, showing a strong upward trend. Also, dummy variables for November and December are significant. Another major strength is that the coefficients are easy to interpret, which is extremely helpful when presenting forecasts to business stakeholders. However, there are some limitations. A few months dummies are not significant. Also, the residual plots show a U-shaped curve, which suggests model may be missing some non-linear effects. And finally, the model assumes that the seasonality stay constant, which might not hold true if customer behavior changes over time. Now let's compare to the winter models. Winter strain dynamically update level, trend, and seasonal factors, which is adapt quickly to changing pattern, making it robust for volatile or evolving data. Winter rollback lacks easily interpretable coefficients. Stakeholders cannot see exactly how much each month contributes. It simply produces mood forecasts. In our test, regression achieved a lower mean square error versus Winter's MSE indicate better historical fit. However, Winter's relatability mean is may outperform when pattern shape unexpectedly. After evaluating both, I believe that each model serves a different business purpose, and the best choice really depends on the context. From a business intelligence perspective, the regression model is more suitable. It's clearly shows the contribution of each month to retail sales, the strength of time trend, and it provides a formula that can be used directly for planning, budgeting, and reporting. This makes it easy to explain to stakeholder and ideal for decision making in stable environments. On the other hand, from business forecasting perspective, especially when market behavior is changing or uncertain, the winter model is more reliable. It adjusts dynamically to the latest data, which makes it better at adapting to unexpected shifts in sale pattern. So my position is this for short-term forecasting and communication. The regression model is better choice, but for long-term forecasting and unexpected market conditions, the Winters model offer better adaptability. Ultimately, a business that wants both clarity and flexibility could benefit from using both models together, using regression for insight and Winters for resilience. That's the end of my presentation. Thank you for listening.